My name is Christian Confer.
James Ritter.
Mark Ritter.
Daryl Collins.
And we are Team Capsule Corp talking about our LAPD data mining results. Now, what we wanted to find when we initially started this was when and where a crime could be committed in Los Angeles. And we want to stress could be because this was never going to be anything more than just a prediction, just a guideline that police officers could use when planning patrol routes and even potentially staging emergency vehicles. Now, we also wanted to be able to predict the likelihood of a homicide occurring at both specific areas and certain times in Los Angeles. And we chose the city of Los Angeles because of its high crime rate and its high population. So we just felt that like we could get more meaningful results with bigger numbers. And we got our data set from data.gov, and what that website is a statistical website where people can go on and put different statistical data, and ours just happened to be for crime statistics in Los Angeles. And the data, of course, is a record of all reported crimes in the city of Los Angeles during the year 2015. And now I'm going to hand it off to Daryl, and he's going to talk about data description.
Okay. Okay, so all the attributes in the data that we use were general pieces of data reported from any type of crime that was reported in LA. The important attributes from the raw data were area name, area ID, crime code, and crime description. I guess the next slide. During the pre-processing part of our data mining project, we added 4 new attributes. And the attributes that we added were time of day, which was morning, evening, early morning, and afternoon. Week zone, which was either weekday or weekend. Zone, northwest, east, central, and day of week, which was either Sunday, Monday, etc.
So to talk about our data mining process, we initially started out with goal 1, which was to achieve or to see if we could predict when and where crimes could occur. And our initial findings using the raw data seemed to be really inaccurate, and there really weren't any relationships or correlations in the data that we could see of at all. And because the accuracy is so low, we couldn't trust the data, and we couldn't say that there was a pattern there or not. So to remedy this issue with accuracy, we need to generalize what we were asking and what we were looking for. Because originally we were looking for how can we predict what's going to happen on, let's say, August 15th at 3 o'clock in the afternoon. And that is very specific. And with just a year's data set, it was very difficult and inaccurate to try to make predictions using that kind of a question. So instead, we needed to generalize what we were asking and say, what can we predict what's going to happen on Sunday in the afternoon? And that is much more broad, and we can make much more accurate predictions and get more meaningful results. So as Daryl was saying earlier, in our pre-processing, we added those 4 other fields which we could use to represent this high-level results. So for problem 1, these were our initial results using our high-level approach. So with these, we could show that on the weekday, afternoon was most prone to or most predicted to have a crime occur, and on the weekend, evenings were the most predicted. And if you see on the right, we have our decision tree logical path, and we decided to go with the decision tree path because it was easy to read and easy to understand. So if you put this in front of a police officer, they can understand the logical flow of these predictions. And we also tried the Bayesian method, and our results were about the same, and we just went with decision tree for readability. Go ahead. And we wanted to continue with this problem and dig down a little more because we thought it was a little too high level initially. So we ended up adding the attribute time of day, as well as day of the week. So with those new attributes that we changed in the select attribute field in our rapid miner process, we were able to get more compelling information. And we got about 35% accuracy with this. And most significantly, it said that in the afternoon, Friday was the most likelihood of crime happening. Saturday early morning and evening, which makes sense just because Saturday is the weekend, people have time off, and stores are unmanned, which could encourage theft or any other kind of crime. One of the most interesting results we got was on Thursdays. On Thursday mornings was the most, or for the highest prediction of morning crimes was on a Thursday morning, which seems, I don't know, we were surprised by that. We would think it may be Sunday morning after Saturday, or even Saturday morning. Go to the next one. So continue. Problem 2 was, can we predict a location where, can we predict where a homicide will happen? So there really weren't that many accounts of homicide, so we did have to increase our training and test set to 60-40 instead of 70-30 as we did previously in our initial setup for problem 1. And with this, we were able to notice that, go to the next slide. We were able to get a good tree that explained the breakout between of predicting day of the week and then the time of the day, which gave us, I think our accuracy was about 40% with a recall of 60, I believe. And along with this, I mean, officers could use this chart here that could show planned routes accordingly. So if they worked on a Saturday morning, they could say, "Oh, we need to keep an eye out in north, or have an ambulance closer to the north area just in case there's a homicide." As our predictions show, that was the most likely. And continued, officers could look throughout this graph and they could plan routes, or ambulances could be in these general areas. Go ahead. And then to continue on, we'll talk about our difficulties with this process and project.
All right. So with the difficulties for this project, we ran into some problems with generalizing our data. The original data set was not generalized enough for us to get valid results and predictions, because with the original data we were getting 0% or 1%, which doesn't help anyone out. And we also had a problem with our questioning. They were also too broad. Like James said, we were looking for specific days and specific times of specific crimes. So bringing it a higher level of day of week and morning or afternoon heightened that. So that was a remedy to the difficulty. And then just another group project difficulty was working remotely and communicating our agenda and our goal for this project and where we're heading with our data processing. And we learned several things after completing this. One was how to pre-process our results, because we didn't get it right the first time, and we had to go back multiple times before we actually got our data to where we can get some viable results. And again, going back to our questioning, we had to rescope those so we could come up with viable questions that we could answer with high predictability. And we also got a good understanding that data mining is for predicting the future and not just simple querying, because originally, before we met with you, we were just doing some simple querying. And lastly, we realized, just for future reference, that when you're constructing a database, it's also very beneficial to keep data mining in mind, so that it's easier to mine the data and not have to do as much pre-processing. All right, and that's all we've got. Hopefully, with these results, LAPD can better predict where crimes can occur and station people there. Thank you for listening. That's all.